Hello, welcome. Today we are here to discuss about the question called question number 237, delete node in a linked list. So this question is quite big to read it, understand it. So let's go through the question and let's understand what exactly they are giving us and what we need to do. So the statement or the question statement says like we need to delete a node. Okay, that is good thing, very simple, deleting a node. But yeah, it's of medium level. So let's see what exactly we need to do here. So there is a single linked list head, and we want to delete a node in it. So there is a single linked list. Let's take a single linked list 10, 20, 30, and 40. So let's say we have a single linked list like this 10, 20, 30, and 40. And we want to delete a node in it. We want to delete a node in it. Let's say we need to delete this node. Let's assume this node. You are given the node to be deleted. You will not be given access to the first node of the head. Okay. So this is the head pointer, right? As we know that head is the one that we get every time to delete or to access or anything. This time what they're saying is there is a linked list. Okay. There is a head. And this is the node that we need to delete. And they're saying they'll not give head. Head is not given. Instead, what they will give this node only. They will give this node only. So node to be deleted. Okay. All the values on the linked list are unique. So we'll have unique values. And it is guaranteed that the given node is not the last node. So they'll not ask you to delete the last node. So they'll give any one of the node from the front. Okay. They'll not give the last node to be deleted. So this is out of the scenario. So they'll give either first node, second node, or third node from the example that we have taken. They'll not give the fourth node to be deleted. Okay. Delete the given node. Note that by deleting the node, we do not mean removing it from the memory. Okay, they are not asking us to remove from the memory, but what they mean, the value of the given node should be not exist in the lens. So this 20 should be removed. Okay, value should be removed, guys. Not so as we know that node has two parts. One is value, one is address, right? D D address. ADD address. The other one is VAL value. Node contains how many parts? Basically two parts. Node contains two parts. What was the first part? What was the first part? Value. Value. What was the next part? Address. Address of next node, basically. Address of next node. Address of next node. So we need to delete that node. So they are saying value of the given node should be not there. So we need to remove the value. That is one thing. And number of nodes in the linked list should be decreased by one. So, okay, we need to delete the value and the number of nodes should be removed, which means here we have how many nodes? 4 nodes. So this 4 should become 3. First thing is value should be not there. Second thing is count also should be reduced. And next thing, all the values before node should be same order. After node should be same order. Okay, the order should be same. So before it has 10, after it has 30, 40. So the order should be same. Okay, this is what we need to do, guys. So the point is they are giving us a linked list. They are giving us a linked list. Okay, they are giving us a linked list where it has head also. Okay, head and all everything. Okay, they have head and all the things are present. So let's take one linked list 10, 20, and also 30, and also let's take 40. Let's take 40 and 40 is pointing to null. Now what they're saying, they will not give you head. Okay. They are not going to give us the head. They are not going to give this one. And they will not ask you to delete the last node. So last node's next is null. So they are not asking to delete the last node. So they'll ask somewhere in between these three. So let's say if they are asking us to delete this one, what they are saying is value should be removed. Value should be removed. Value should be removed. And one more thing, what they're saying, count should be reduced. Count should be reduced. count should be reduced. Value should be removed, count should be reduced. First thing, I need to remove the value, which means 20 should not be there. And I need to delete a node. But I can't delete this node. No, I can't delete this node. I can delete only this node. As we know, if I want to delete a node, I need to stay one step ahead. So I can delete 30. But if I delete 30 node, I will lose this 30 value. Okay, I will lose this 30 value. So what we have to do here, we need to simply store this 30 value into current node. 30 value will be stored here and delete this node link to 40. That's all. Copy the 30 value, which means 20 is removed. First condition is true. And reducing means delete the 30 node. Why we are deleting 30 node? We have already copied the data. So 10 will be there, 30 will be there, and 40 will be there. Order is also not changed. Okay, I hope you understood this, guys. So simply copy the value to the given node. Copy the value to given node and delete that node. This is what we need to do. Okay, this is what we need to do. So let's take an example here again. 10. 10's next is 20. 20's next is 30. 30's next is 40. And 40's next is null. 40's next is null. One guarantee that we have is they'll not ask us to delete the last node. They'll not ask us to delete the last node. This is the one guarantee. Let's say if you are deleting 30, they will asking us to delete the 30. So if they are asking us to delete 30, they will give access to this only. They will give access to 30 node. Now what I have to do, I have to remove the value. To remove the value, I will copy this value 40 to this node. So this node value will become how much? 40. 40. And after that, what I need to do, I need to delete the next node. Why I need to delete the next node? I have copied the value. So value is there, delete the next node, point this to null, point this to null. Okay. So when you are, so they'll not give access to last node, which means last node next, we don't have anything. So I can't delete this node by giving this node's address. So if I give access to last node, I can't delete it because last node, that's all. We don't have anything next to copy and remove. So that's why they are clearly mentioned. I will not give you last node's address. Last node's address. I'll give you only in between nodes. Okay. So we need to simply do this one. Copy the value and remove the next node. That's all, right? That's all we need to do. Okay. Let me clean this one. 1 second. Let me clean this. Close this. We don't have much, guys. Node is given. Node is given, which means current node to be deleted. Current node to be deleted. So what I need to do? Copy next node value to current node value. So how to get current node value? Node dot value. How to get next node value? Node dot next means next node. Dot value means with value. Copying node next node value to current node. After that, delete next node. Delete next node. How you will delete? Node dot next equal to node dot next dot next. Node dot next dot next. You can say, you can ask me, why don't we get a null pointer exception? We will not get null pointer exception because they are not going to last node. They'll obviously give somewhere in between. They'll not give you the last node. They'll not give you the last node. That's what the confidence that we have, that we will not get a null pointer exception. That's all, guys. This is what we need to do. So let me run this one. Let me submit this. So this is what we need to do. Simply copy the value and delete the next node. I hope this is clear. I hope this is clear. So this is what we need to do, guys. I hope you understood this one. Thank you.